So, just like you, I don't have the FRQs printed, so I'm going to be drawing and writing what I need to as we go along, okay? The figure above shows the graph of f prime, the derivative of twice differentiable function f, on the closed interval from 0 to 8. The graph of f prime has horizontal tangent lines at 1, 3, and 5, and the areas are labeled in the region, and then f of 8 equals 4. So first I'm going to draw it as best I can. So I know that at 1 it hits the x-axis, and then 2, 3, it's maximum. 4, it crosses the x-axis. 5, it's got a minimum. 6, it crosses the x-axis, and then 7, 8. Okay. 4, 5, 6. Okay, so 2, 3, 4, 5, 6. So we start here. We come down, reach a minimum, have a maximum at 3, 4. 1, 2, 3, 4. Cross here and have a minimum at 5, -2. Well, that was kind of bad. And then come back up. Whatever. And then across there, and then have a max at 8, 5. So 8, 5. Something like that. Okay, and then the areas are 2, 6, 3, and 7. Circle those so we know that I'm talking about areas, as opposed to the scale 1, 2, 3, 4, 5, 6, 7, 8, and the y values, which are at 4, -2, 5, and 6, that we need to know potentially. Okay, this is the graph of f prime. So I'm going to come back to that in a little bit. And then one other thing we need to know is that f of 8 equals 4. So that's going to come into play at some point. So part A, find all values of x on the open interval from 0 to 8. So on the open interval from 0 to 8, for which the function has a local minimum. Okay. So just as a reminder, we know that f has a minimum when f prime changes from negative to positive. Yeah? So if I keep this in mind, this is what I'm trying to do. I can go ahead and even say that f has a local min when f prime changes from negative to positive. And then I can just go over here and look. So when does f prime change from negative to positive? F prime is positive, equals 0, positive, positive, negative, negative, and then positive, right? So the only time f prime changes from negative to positive would be at x equals 6. So I would say x equals 6 is my answer. But this is my justification. And I think that's all we need. Yep. Okay. B. Determine the absolute minimum value of f on the closed interval from 0 to 8. So absolute min on the closed interval is 0 to 8. Justify your answer. Okay, so a couple things. We're trying to find an absolute extrema on a closed interval, which is extreme value theorem. We have multiple critical points. We have a critical point anytime the derivative equals 0, which is here, here, and here. True. I would think that we could narrow it down to 3 options, our endpoints and 1 critical point, because at one of them, f prime doesn't change sign, and at the other one, at this one, f prime changes from positive to negative, indicating maximum, so it could not be a minimum. So I think we could get away with only really addressing, other than justifying why we're not going to put them in the t-chart, 0, 6, and 8, but I'm going to make sure. Yeah. Okay. So let's go ahead and address those points that we don't need to worry about. Otherwise, you need to put all critical points and endpoints in your t-chart, and that's, it's just whatever you want to do. So I'm going to say f prime equals, f prime of x equals 0 at x equals 1, 4, and 6. But then I would say x equals 1, f prime does not change sign. Not a min. And then at x equals 4, f prime goes from positive to negative, which is a max, not a min. And I think that would be just fine in order to justify why you're not including them in your t-chart. Okay? So what I'm going to do is I'm going to do t-chart with x and f of x, and in our t-chart we're going to put 0, our possible absolute minimum 6, and then 8. Now remember, you're supposed to use calculus on how you're finding this, right? So I've got the graph of f prime and I want to find the value of f. So what I need to do is remember that my fundamental theorem allows me to find the value at a number if I've got another number and I've got another amount and I've got the rate of change. F of 8 equals 4. So this is a year that they got kind of tricky, and they were like, you know what, we're going to stop giving them the initial point, we're going to give them the final point that they start at. Now you could absolutely think this out. I end at 4 and then I go and then think areas backwards, but I think it'd be easiest for us to say this. F of 0, right? If I'm trying to find that, let's write out to the side the integral from 0 to 8. And the reason why I'm using 8 is because that's the value I know. Of f prime of x equals f of 8 minus f of 0. So if I'm trying to solve for f of 0, then what I'm going to do is I'm going to add f of 0 and I'm going to subtract the integral from 0 to 8, which makes sense. You take your final position and you subtract your change in position, right? So if I'm going to solve for f of 0, I'm going to add it over here. So f of 0 equals f of 8 minus the integral from 0 to 8 of f prime of x dx. This integral is key because it's the calculus connection, yeah? So f of 8 equals 4, and then what we're going to do is we're going to subtract all these areas. So if you're going backwards, this is a positive area, but now we're going to subtract it. So minus 7 plus 3 minus 6 minus 2. Okay, now normally I would say leave it alone, but we are going to have to identify which one is the lowest value of the values at 0, 6, and 8, so we do need to simplify this. This is non-calculator. So that would be negative 4, so those cancel each other out, negative 8, negative 4 plus 4, and then negative 8. So we'll say the function at 0 is negative 8. So let's do the same thing for 6. Although we can kind of skip a step if we need to. The integral from 6 to 8 of f prime equals f of 8 minus f of 6, or you could just jump to f of 6 equals f of 8 minus the integral from 6 to 8 of f prime of x dx. So f of 8 is 4 minus, what we're going to do is we're going to subtract this area. So from the area from 6 to 8 is a positive 7. We're going to subtract 7, so that's a negative 3. So definitely not the absolute minimum. So far it's looking like x equals 0 is the absolute minimum. And then f of 8. So f of 8 is just going to be the integral from 8 to 8 of f prime of x dx. Oh, I'm just kidding. Huh. We know f of 8. F of 8 is 4. I don't know why. Interesting. Okay. So, we could say, therefore, the absolute min of f on on the interval from 0 to 8, so including 0 and including 8. Did they say the absolute minimum? They said the absolute minimum value is -8, and if they'd said at what, you could say at x equals 0. But I think you could just say at x equals is -8. Okay. Part C. On what open intervals contained on the interval from 0 to 8 is the graph of f both concave down, f concave down, and increasing? And then we've got the interval from 0 to 8, so we're not including endpoints. Okay, so this is kind of interesting. When is f both concave down and increasing? What we want to do is use our little charts, yeah? So here's what I know. I know f is concave down when f prime is decreasing. And so here's the thing. I know it's when f double prime is negative, but what are we given the graph of? We're given the graph of f prime. So I'm going to address this, right? So this is what I want to know, when f prime is decreasing. And then further, when is f increasing? F is increasing. So f is increasing when f prime is positive. So these are the two things I need to know about f prime. When is f prime both decreasing and positive? So that's what we're going to write down. When f prime is both decreasing and positive. And so then I look back at my chart. F is both decreasing and positive, or f prime. Decreasing and positive, I agree, from 0 to 1. Increasing, decreasing and positive, I agree. So from 3 to 4. So from 0 to 1, 3 to 4, decreasing negative, increasing positive. So decreasing and positive only from 0 to 1 and 3 to 4. Check and make sure that we got those. And yep. Okay. So the last question, part D, or last part, it says the function g is defined by g of x equals f of x cubed if f of 3 equals -5/2, find the slope of the line tangent to the graph of g at x equals 3. So slope of tan line of g at x equals 3. Now, when they say slope of the tangent line, they don't mean find the tangent line, and they don't mean, you know, anything. It's not like anything different other than just find the derivative. The tangent line at a point takes on the slope of the curve at that specific point, so all we need to do is take the derivative. So g prime equals chain rule 3, leave the interior alone, to the second power times the derivative of the interior f prime of x. And then if I want to find g prime at 3, then that's 3 times f of 3 quantity squared times f prime at 3. So f of 3 is -5/2, so 3 times -5/2 squared times f prime at 3. And if I go back to my graph, f prime at 3 is 4. And we could leave it like that. You could just say, there's my answer. You could say 3 times 25, 4 times 4, so 75. But if you just left it like that, you would also be correct. And there we go. So that is your first one. So I'm going to label that set 1, number 1. Okay. Now let's do set 1, number 2. Sorry, I'm gonna. Okay, there we go. it says, consider a differentiable function f having domain all positive real numbers for which it is known that f prime equals this. Okay. Okay. No, just kidding, I skipped one. How did I skip that? Okay. The figure above shows the graph of f prime, so I'm going to graph that real quick. It crosses at crosses at -2, but it goes to -3, so -1, -2, -3, and then it goes to 4. So 1, 2, 3, 4. So at 1 we've got a maximum, we cross at -2, and we touch at 4. So it doesn't really give any indication of y value, so whatever, we'll just do this. You might want to draw it on your own paper just so you have, like on your FRQ, so you have a graph to reference whenever you're working, and you can reference it as you work your problem, especially if you look back at it, which I'm sure you're all going to do to study for your exam. Was that minimum supposed to be at -1? Yep. Okay, so this will be a minimum there. Where's that minimum supposed to occur? Oh, that was supposed to occur at 3. Dadgummit. Should have paid attention to that. This is the graph of f prime. Alright. Has horizontal tangents at -1. Is 1 and 3. The areas, okay, so from -2 to, let's see. From -2 to 1, that area equals 9, and this area equals 12. Okay. Find all x coordinates at which f has a relative maximum. Give a reason for your answer. So part A. Did they give me anything else? Okay. Relative max at x equals what? So let's going back to what we just talked about. F changes from increasing to decreasing, having a max when f prime changes from positive to negative. So I would say f has a max at x equals positive to negative, -2, because f prime changes from positive to negative. Okay, part B. Guess I'll do that. On what open intervals contained in the interval from -3 to 4 is the graph of f both concave down and decreasing? F concave down and decreasing. Give a reason for your answer, and we're only looking on the interval from -3 to 4. Okay, so f is concave down when f is concave down when f prime is decreasing. Cool. F is decreasing when f prime is negative. So f is decreasing when f prime is negative. So f is concave down and decreasing when f prime is both decreasing and negative. Please don't use a down arrow for decreasing, because I don't think that they like that or accept that. Okay, f is both decreasing and negative. So decreasing but positive, decreasing and negative. So if we would say -2 to -1, decreasing and negative, increasing and negative, decreasing and negative, so from 1 to 3. And then increasing negative. So there's our answer. Part C. Find the x-coordinates of all points of inflection on the graph of f. Give a reason for your answer. So POI. X-coordinate only. Okay. So F has a POI, which is a change in concavity. F has a point of inflection when F prime changes from increasing to decreasing, or vice versa, right, because it could go backwards, or when F double prime changes sign. But the fact of the matter is that we're looking at F prime. So I would say F has a POI when F prime changes from, and this, by saying this I don't have to be specific, from increasing to decreasing, or vice versa. And then we just look at our chart, our graph. When does F prime change from increasing, decreasing, or vice versa? So decreasing, then increasing. So that's at x equals -1. Increasing, then decreasing, x equals 1. And then decreasing, increasing, x equals 3. And that would be enough to get those points. So all it says is, yeah. Okay, cool. And then part D. Given that f of 1 equals 3, write an equation for f of x, write an expression for f of x, that involves an integral. Find f of 4 and f of -2. Okay. So here's the thing. If you want an expression for f of x, remember f of x has to be part of your x has to be part of your integral. And the idea is that I can find f of 4, I can find f of -2 by just plugging in 4 and -2 for that. So here's what I know. I know f of 1. I want f of x. Yeah? I also know f prime. So using the fundamental theorem of calculus, I know that the antiderivative from 1 to x of f prime of x dx equals the antiderivative of f prime is f, so f at x minus f at 1. True? So if I'm trying to solve for f of x, then all I gotta do is add f of 1, initial plus change. So f of x equals f of 1 plus the integral from 1 to x of f prime. Crap. Okay, I can't do that. This can't be an x and this also be an x, so this is going to have to change to a t. And then dt. My bad. So, the idea being, if I plug in for an x, I can't plug in an x here, and there. It's got to be only just for this value, and this is just f prime at t. So a different variable. So, that's my function for f of x, although f of 1, we'll go ahead and say 3 plus the integral from 1 to x of f prime of t dt. So then when they ask me to find f of 4, it's just 3 plus the integral from 1 to 4. And the integral from 1 to 4 is going to be this area down here. It's going to be 12, but we are going forwards and it's below the x-axis, so that's going to be minus 12. So 3 minus 12, that's going to be -9. And then f of -2 means 3 plus the integral from 1 to -2 of f prime of t dt. Keep in mind here that we're going the integral from 1 to -2, so whatever this area is, positive or negative, we're going to switch it. So it's going to be 3. Going from 1 to -2, this area is 9. It is below the x-axis, so normally I would say -9, but since we're going backwards, it's going to be +9. So that area is 12, or that value is 12. And there we go. So for part A, It was worth 2 points, identifying x equals -2, and then your answer with your reason. Part B was worth 2 points, one for your intervals, and then one for your reason. So this was worth 1 point, and then your reason was worth the other point. Part 3, identifying those 3 points was worth 1, and then your reason was worth 1. And then Part D was worth 3 points. So you got 1 point for the integrand, meaning you took the antiderivative of f prime, right? 1 for the expression, just f of x equals, so that would be this thing right here. And then 1 for these two values, so you couldn't get just one of them and not the other. Okay, there's the second one. So AB set 1, problem 2, and then we have one more. Consider the differentiable function f having domain of all positive real numbers for which it is known that f prime of x. So f prime of x equals 4 minus x times x to the -3rd for x is greater than 0. But f has domain all positive real. So same as x greater than 0. Okay. A. Find the x-coordinate of the critical point of f. So x-coordinate, critical point of f of x. You wouldn't need to write this down on the FRQ, it would all be there for you, but since we don't have it written down, let's just, write down the things that we need to find. Determine whether the point is relative max, min, or neither. So relative max, min, or neither. Okay. So what I want to do is I want to actually look at what f prime is. F prime equals 4 minus x over x cubed, if I bring that down, right? So if I look at when does, what are my critical points? Normally I would say critical points are when the derivative is 0 and undefined. So I know it's 0 at x equals 4. And I know f prime is undefined at x equals 0, but x has got to be greater than 0, so I don't need to worry about it. Okay, so my only critical point that I need to worry about is x equals 4. So then it's the question is whether or not you have a max, min, or neither there. We could do a sign chart, or we could do the second derivative test. I'm going to do both just to remind you. So first derivative test for extrema, I would set 4 for f prime. I'm going to remember that 0 is a critical point technically, but that means I don't plug in -2 and think that's going to work for that, okay? So I'm going to plug in, although that should be fine, I'm going to plug in 3. 4 minus 3 is positive over positive, so that's positive, and then I'm going to plug in 5, that's negative over positive, so that's negative. So I would say f has a relative max at x equals 4 because, don't forget to verbalize your sign chart, they do not grade a sign chart, because f prime changes from positive to negative. Okay? I do want to remind you of the second derivative test, so I'm going to do that right quick. Second derivative test for extrema. I'm going to find the second derivative, so f double prime using the quotient rule. So low, d high is -1, minus high, 4 minus x d low, which is going to be 3x squared, all over low, which is x to the 6th, x cubed squared. Okay. If I were to simplify my numerator, it would be negative x cubed. Let's see, if I distribute my 3x squared, it's going to be minus 12x squared, and then plus 3x cubed, which is going to be 2x cubed minus 12x squared. 2x cubed minus 12x squared over x to the 6th. If I factor out, I don't need to do all of this at this point, but I do want to go ahead and simplify it. If I factor out an x squared, a 2x squared in fact, then I'm left with x minus 6 over x to the 6th. And then I can simplify out two of those, leave me with 2 times x minus 6 over x to the 4th. So, what do I need in order for the second derivative test to work? All I need to do is find the second derivative, which I could have stopped here, and then plug in my critical point. I already know that the first derivative equals 0 at x equals 4, okay? Writing this down is the potential for a single point on almost every single FRQ if there's a derivative. If there's a, critical point or anything. When the derivative equals 0, labeling that. For the second derivative test, all I gotta do is plug in the critical point into the second derivative. So that's 2 times 4 minus 6 over 4 cubed. 4 minus 6 is negative. This is a negative number, okay? If you have a max, then that means at the maximum your slope is 0 and you're concave down. If you have a minimum, your slope is 0 and you are concave up. Well, because f prime of 4 equals 0 and f double prime of 4 is negative, f has a max at x equals 4. Not necessarily, definitely not easier than the sign chart in this case, but sometimes you have no choice but to understand what the second derivative test is, because all you're given is some information about the first and second derivative, not a function that you can actually do a sign chart with, or a first derivative function anyway. So anyway, there we go. Let's see, that was worth 3 points, 1 for identifying x equals 4, 1 for saying it was a relative max, and then 1 for saying that, or for your justification. Okay. Part B. Find all intervals in which the graph of f is concave down. Okay. So, here's the thing. I went ahead and found the second derivative in part B, or in part A. So, concave down. We want all the intervals. I'm going to go ahead and find the second derivative using, instead of quotient rule, I'm going to use product rule, just to find it a different way to kind of show you. So f double prime, see if we get the same thing. So f double prime means take the derivative of the first, or first times the derivative of the second, whatever you want to do. So I'm going to say first, 4 minus 6, times the derivative of the second. The derivative of x to the negative third would be bring the power down to the front, subtract 1 from the power. So negative 3x to the negative fourth. So first times the derivative of the second plus the derivative of the first. The derivative of 4 minus x is negative 1 times the second x to the negative third. And then what I would have to do is say, okay, so that's negative 3 times all that. So that's negative 12 plus 3x all divided by x to the fourth. So the negative 3 doesn't go to the denominator, just that. So negative 3 times all that. And then minus 1 over x cubed, common denominator, multiply top and bottom by x, and then I would say negative 12 plus 3x minus x all over x to the fourth, which is 2x minus 12 over x to the fourth, or 2 times x minus 6. And there we go. Okay, now that gives me my second derivative. It does not give me my POIs right off the bat, okay? You have to, well, we are looking for points of inflection, kind of. If they had said points of inflection, this would be even more critical right here. X equals 6 and x equals 0 are times when the second derivative is 0 or undefined. That does not automatically make them POIs. So a POI occurs when the second derivative is 0 or undefined and changes sign. And I hope that you would recognize that with having x to the fourth in the denominator, the second derivative would not change sign at 0. It would bounce, if you will, on the signs. But we're only dealing with x greater than 0, so I don't need to worry about that. So we're going to do a sign chart for f double prime. I am going to put 0 as a boundary, but we're not including it, and then I'm going to put 6. Okay? Because if I'm concave down from 0 to 6, then I can't say from negative infinity to 6, because we're only talking about for x is greater than 0. I got to say from 0 to 6. So those boundaries are very important in the prompt. I'm going to plug in 5. So if I plug in 5, 5 minus 6 is negative, so that's going to be a negative there. And then 7, that's going to be positive there. So I would say F is concave. I cannot write the word concave. Concave down on the interval from 0 to 6 because F double prime is negative. And that would be my justification there. Okay. So for this one, it was worth, this part was worth 3 points. You got 2 for finding the second derivative, and then you got 1 more point for your answer with justification. But your answer had to be from 0 to 6, not from negative infinity to 6. Alright, last part. Part C. Given that f of 1 equals 2, determine the function f. Alright, they really like to do this, yeah? We have a couple options. Let's see. I'm going to work it 2 different ways. One is to use the fundamental theorem, and the other is what some of you are more drawn to, which is just anti-deriving and then solving for C. So I'm going to do it both ways. Let's see. Okay. So a lot of you would think, let me just anti-derive f prime, which is going to be 4 minus x over x cubed dx. And I'm fine with that. So you would say f of x equals, right? And then the antiderivative of f prime and then plus c. So, I don't know. It might be kind of problematic to say f of x equals, but we'll go with it. As far as anti-deriving goes, if you try and do a u and a du substitution, if you say u equals x cubed and du equals 3x squared, you don't have that up here. You just got to remember that when you got one term in the denominator, you can split this up. So you can say the integral of 4x to the negative third, or 4 divided by x cubed, minus, and then x divided by x cubed is x to the negative second in the denominator, so x to the negative second. So we're just anti-deriving these two terms. Okay, we just split up the fraction, divide them each. 4 over x cubed minus x over x cubed. Add 1 to the power, divide by the new power. If you add 1 to the power, you get negative 2. If you divide by the new power, you get negative 2. Add 1 to the power, you get negative 1. Divide by the new power, you get plus, and then plus c. So f of x equals this, which is just negative 2 over x squared plus 1 over x plus c. And then we're going to use our initial condition, f of 1 equals 2. F of 1 equals 2. And say 2 equals, we're going to plug in 1 for x. So negative 2 plus 1 plus c. So that's negative 1 added over, you get 3. So 3 equals c, which means f of x equals negative 2 over x squared plus 1 over x plus 3. And that would be my function for x greater than 0. That's the domain they gave me in the original, so that's what I'm going to do. Okay, here's the other option. Some of you definitely like this. This makes better sense to you than the fundamental theorem, but I am going to keep doing the fundamental theorem because it's going to be very important that you're comfortable with it. Here's what I know. That if I want to find the f of x, and I've got f of 1, then I can just do the fundamental theorem and say that the integral from 1 to x of f prime of t dt equals f at x minus f at 1, which means f of x equals f of 1 added over, so that's 2, plus the integral from 1 to x of f prime of t dt. So I just got to change the variable. So here's what we got. 2 plus the integral from 1 to x of, and I'm going to go back to this, 4t to the negative third minus t to the negative second dt. So I'm just going back to what we have over here. We would antiderive, and we would say 2 plus, and our antiderivative was negative 2 over t squared plus 1 over t. We would say bar from 1 to x. Then we would plug in x and plug in 1 and simplify. So it's 2 plus, so first we're going to plug in x. So negative 2 over x squared plus 1 over x minus, now we're going to plug in 1. Negative 2 over 1 plus 1 And all of this still equals f of x. So I've got 2 minus 2 over x squared plus 1 over x, and then this is negative 1, so that's going to be plus 1. And you can see how that is the same thing as just adding 3, and I could rewrite it with 3, but we have it right here. So there we go, which is just that, but for x is greater than 0. Okay, I hope both methods make sense to you, because this is going to be very important, but this is also an option for you. Alright, that's the end of that.